So welcome all. Today we are discussing something about routing information protocol. Basically we have already discussed about distance vector protocol, distance vector routing algorithm, right? So this routing information protocol is totally based on that distance vector routing algorithm. So here we are today discussing something about the packet formats and little details of this protocol rather than discussing about distance vector protocol. So you can see the earlier video for this thing, distance vector routing algorithm. So here in RIP actually what we are going to do is we are just using this distance vector routing algorithm, and we can understand that there are routers. What distance vector routing has to do, it will maintain certain table at all the routers. And RIP is a standard protocol which is to be used inside an autonomous system, which will help you transmit this information between one router to another. That is a simple thing. So let me tell you that these are the things we are going to see. We will see the RIP message format, we will see the request response formats, how requests are made by some routers, how some routers make a response, what are the role of these timers that okay, 16 or something, some timers are there, okay, which we will see. If what are the difference between version 1 and version 2 of RIP, we will see that yeah, encapsulation is also being done in version 2. Okay, so let me show you this simple I should say example, where you can see we have 4 routers, R1, R2, R3 and R4. Okay, and these are certain small networks which are related to these routers. So here are the tables I can show for these routers. So this is router 1, router 2, router 3. Accordingly we have these tables for router 1, router 2, router 3 and router 4. If you try to understand this router 1 table, you will understand, as if you have seen the earlier video also, you will easily understand that these are the destination address. So this is 130.10.0.0.16. This is the one network N1. This is 11.0. This one N2. So N1 and N2 are just directly connected to this router R1. So in the next column, in this column, the third column, where we actually store the information of next hop, this is blank. Why? Because you don't need to go to another router for going to this network, for delivering something to this network N1 or N2. So actually what is happening now, for other networks, whatever, if some address is from this network 2.4.0, right, you will understand 2.4.0 is somewhere here, I think. So it will try to find out where it has to send this packet. So it will reach here in 2 hops. It will send the data to 130.10.0.1. okay, that will be its router. So that is how the packets will be transmitted, whether this side or this side, or maybe if the packet has to be sent here, it will reach in 3 hops. So that is the thing. In this way these tables are being maintained at all the routers. Now in case some router has just boot up, or maybe something happened and some link failure took place, something, they need to update their table. In that case they will have to request for something to their neighboring routers, and these neighboring routers will reply with the table content, actually I should say. And you can say that in an autonomous system, within an autonomous system, whatever the routers are, so all the routers have all the information of all the networks, right? You can see you have how many, 7 networks, right? N1, N2, 2, N7. So each table is having 7 entries that you want to send a packet to this particular network. So you need to know through which router this particular packet has to be sent. So this is very clear that within an autonomous system, whatever the networks are, you will have to maintain the information of all those networks. That is the thing, very simple. Now let me show you the RIP message format. If you see this message format, you will understand that the first field is command. You see, this command is basically 8-bit field which actually specifies the type of message. It will tell you whether the message is a request message or a response. For request it will be, the value will be 1, and response it will be 2. If okay, the second field is version, again 8-bit field, which will define the version. You can understand the version can be 1, later on now it is version 2. That is the thing, it can be there. Other next 16-bit is okay, reserved. Then family, it is again 16-bit field which will define the family of the protocol being used. Maybe family, you can understand it is TCP/IP protocol suite. So usually it is TCP/IP, if at all it is something like that. For TCP/IP the value is 2. Okay. Now you can see the next field is all zeros, let be. Then it is a network address, right? What the network address means is actually the address of destination network, right? So for this 14 bytes has been allocated, right? So this is something we know that this IP addresses actually use 4 bytes, but still 14 bytes have been allocated to it. Rest of the field will be 0, no problem. Okay. Now distance is something, it is actually 32-bit value, 4 byte, actually 32-bit I should say, which will tell you the hop count, between between these two, this advertising router and the destination network. Okay, so total hop count. So this is a simple RIP message format. Let me tell you about the request messages. Simply if it is a request message, actually I should show you this slide, next slide also, but the thing is, request message is sent by a router, means a router which has just woke up, means just booted, or maybe a timeout has happened. In that case it will send a request message. It will ask it can ask for some specific entries. It will specify the network address, or it will keep all zeros and ask for all the entries, whatever entries you have, the next router send me all the entries. That is the thing. And so this is something, and the response message will be either solicited or unsolicited. Means solicited is one response where only one answer is given, right? That is the thing. Means the network address was given, and accordingly we have to tell them that this is the particular distance of this particular network, right? Unsolicited, it is basically actually when some periodically it is sent. Okay, see, suppose 30 seconds or whenever the routing table changes, then this information is sent. So it will be called as unsolicited response. So sorry. So now there is something called timers. If you will understand something about this, it controls the advertising of regular update message. Uh, Periodic timer means it can be usually 30 seconds, maybe between 25 to 30 seconds. It is periodic timer. Okay, another can be expiration or garbage collection timers. So expiration timer actually governs this the validity of a route. When a route actually receives update information from a this router actually receives update from update for a route, then the expiration timer is set to 180 seconds for this particular route. So every time a new update for the route is received, the timer is reset. So what happens in normal situation, this occurs every 30 seconds. That is the thing. So the route is considered expired. Okay, actually when the route is considered expired after 180 seconds. So 180 seconds after that the route is considered expired, and the hop count of the route is set to 60. 16 is as we understand it is infinity, right? Unreachable. So it may happen that every route may have its own expiration this thing. So just wait a minute. So I was telling you about this garbage collection timer, where you have to understand that information of a particular route is being maintained in a table, right? This routing table. After some time, some route information may become invalid, but just because it is invalid, it is not purged right away, immediately. So instead of that, what we do, uh, it is continuously advertised by keeping this metric as metric value 16, the infinity, and this garbage collection timer is set to 120 seconds. And then what happens as this timer becomes 0, and till that time this route has not become valid, then this particular route is purged and then removed from the table. So for that purpose this garbage collection timer is used. So now there is something called the version of version 1, version 2 of this particular this thing, RIP. So there are very few changes and few important things, whether I have kept that packet here or not. Yeah, oh sorry, I should have kept there only, but this is the packet format of version 2. So along with the earlier things, you can see one new thing here, it is root tag. Okay, so this field carries information of this I should say autonomous system number. Actually it will be used to enable this protocol to receive information from an inter-domain routing protocol. Okay, so for that purpose this root tag is used. Another thing is network address. You already know subnet mask, okay, next hop address and distance. Two new things you can see here, subnet mask and next hop address. So actually in RIP version 1, what was happening, it was totally based on that class full addressing. Now it is helping you in classless addressing. So somehow you can understand, just because we want to support this classless addressing, we are keeping this form of subnet mask also. That is the thing. Next thing is next hop address. So name is clear that we want to store the information of next hop. The question is why this is how this is useful, right? So actually it is useful if two autonomous systems share a network, right? Maybe there is a particular backbone, for example. Then if two networks are sharing a network, in that case this particular mm, next hop address is helpful. So this message can define a particular router. So this in the same autonomous system or another autonomous system. I know. So in this way, this next hop address can help you for going in the next autonomous system. Okay, wait a minute. Now this is something you have already seen. I was telling you about. Yeah, along with this classless addressing, there is something called authentication which is included, which means now that was a packet format here. Here the thing is, say there is 16 bytes. Actually this authentication is added to protect the message against unauthorized advertisement. No new fields are added to the packet. Instead, the first entry of the message is set aside for authentication information. That is the thing. Now if you want to indicate that the entry is authentication information and not routing information, then what you do in this family, you keep this value, hexadecimal all F. That is the thing. And this second field is authentication type, which defines the protocol used for authentication. And this is authentication data itself. So this is how this authentication message can be sent from one router to another. So this is allowed in version 2. Now there was something called encapsulation, and actually what happens in actually RIP, the thing is it is encapsulated in UDP packets. Okay, yeah. So in UDP user datagram, this particular RIP messages are encapsulated. So in that case, this RIP message does not include any field that indicates the length of messages. So how can this be determined? This can be determined from the UDP packet. And you can see it is running on this well-known port 520. So this is something related to RIP messages, RIP protocol. Okay. So some questions you can see, if at all, some examples. A routing table has 20 entries. It does not receive information about 5 routes for 200 seconds. So how many timers are running at this time? Okay. So you can understand there are 3 types of timers. One is periodic timer, which is see the 21 timers are listed below. One timer is periodic timer. Expiration timer are 20 minus 5, it is 15. I know. Now for 5 routes, actually from 200 seconds we haven't received information, so garbage collection timers are running for these 5 entries, and for other 15 entries expiration timers are running. So that is something we have to understand. So this is all for RIP today. Thank you.